Hi everyone, today is January 9th and we are looking at the medium daily integral for today. As always, please pause and try it out for yourself. And now we'll start. So, this form, let's rewrite this in a little bit different manner so we can really see what's going on here. So we have a square root, x minus x squared to the third dx. So this form right here should immediately remind you of doing a trig substitution. However, for a trig substitution, we can't just use this as is. So what we're gonna have to do here is take x minus x squared and complete the square. So that's what we'll do now. So x minus x squared is the same as negative x squared minus x. So we're gonna make this into negative x minus 1 over 2 squared plus 1 over 4. So here we have completed the square, and now we have 1 over 4 minus x minus 1 over 2 squared. You can check this over. This is what you will get if you complete the square. So here we have this, okay? What our goal is this is really in the form of a squared minus x squared. So here we have two options of, so here a is really like not equal to 0, and it's just like any real number. And now what we're going to do is we need to make this into a way which we can integrate. So what are we going to do? We could let x be cosine of theta over, a times cosine of theta, and then we'll get a squared times 1 minus cosine squared theta, and then of course we have our d theta and everything. But the point is, we could do a substitution of x equals a cosine of theta like this. In this case, we're going to have to modify this a little bit. So we have a squared, let's keep this down here. So we have a squared, okay. Let's remove this and just have a squared minus x squared here. So in this case, our x squared is x minus 1/2 squared. So how can we make it so we get rid of that 1/2 in parentheses? Well, we can do, let's use cosine of theta. We could here use cosine of theta or sine of theta. It will not change the answer. Let's say we use cosine of theta. So x will be equal to cosine of theta with some coefficients, of course, plus 1/2. So when we plug this in, we'll get cosine of theta squared. Since the minus 1/2 and the plus 1/2 cancel out, we'll get cosine squared of theta in there. So now we need to make sure that we consider that this 1/4 factor here. So we want to get cosine squared theta over 4. So for that we can just divide cosine theta by 2. So here we have our new substitution, and we'll have now x. Let's rewrite this a little bit neater. We'll now have x is equal to cosine of theta plus 1, all of this times 1/2. Okay? So now let's actually start solving this integral. Let's first switch the bounds. So let's first switch the bounds. So we have 1/2 is equal to cosine of theta plus 1. So that's the same as 1 is equal to cosine of theta plus 1. So if cosine of theta equals 0. So remember that when we're taking our cosine, we have to consider the range. So we have to consider the domain. So here we can just let this be pi over 2. That's what's going to fit in our domain. Now let's plug in 1/3. So, 2/3. 2/3 is equal to cosine of theta plus 1 times 1 over 2. Multiplying by 2, we get 4 over 3 equals cosine of theta plus 1. So 1/3 is equal to cosine of theta So we have theta is equal to arc cosine of 1 over 3. So that's our upper bound. Okay, theta is equal to arc cosine of 1 over 3. So here, now we have from pi over 2 arc cosine of 1 over 3. Let's get rid of this scratch work. And bring this up here. So now we have that x is equal to cosine of theta plus 1. So times 1/2. So let's just rewrite this like this. It's 1 over 2. So our dx is going to be, the constant is 0, so we'll get negative 1 over 2 sine theta d theta. Okay, now let's plug in x equals 1/2 cosine of theta plus 1/2 into this right here, this part. Well, actually, let's first rewrite this here with our actual thing here. So we'll have 1 over 4 minus, it's minus 1 over 2 squared. This is cubed like this, dx. So here, let's say we plug in. Let's just write this all out. This will be a little long. 1 over 4 minus, so we have 1/2 cosine of theta plus 1/2 minus 1/2. This whole thing is squared. Then all of this is cubed. And then we have negative 1 over 2 sine theta d theta. And this will start cancelling out very nicely. So if this cancels out here, and then arc cosine of 1 over 3, 1, all of this is over 1/4 minus, so this canceled out. So we'll have 1/2 squared, so that's 1 over 4 cosine squared theta, all this is cubed, d theta. So again, we'll add our bounds. So we can factor out a 1/4, and that'll leave us with 1 minus cosine squared of theta. Well, what's 1 minus cosine squared of theta? Well, that's sine squared theta. And then we'll take the cube outside, since that won't make a difference. This will just make it easier for us to work with. And I notice here that I forgot my negative half sine theta. Negative half sine theta d theta. So into negative half sine theta d theta. So now we can really simplify this all out. Arc cosine of 1 over 3. 1, all of this over 1/4, so that's 1/2 sine theta, right? And we won't need to worry about absolute value right now, since on this interval, pi over 2 to arc cosine of 1 over 3, our value will be positive for sine. So worrying about the absolute value will not be needed here. So now let's see what we get. So we'll have 1/2 sine theta. This is cubed times negative 1/2 sine theta d theta. One of these is going to cancel out. So 1/2 sine theta, that cancels out. We make this into 2. So now we have negative pi over 2 to arc cosine of 1 over 3, 1 over 2 sine theta squared d theta. This is now equal to negative pi over 2 arc cosine 1 over 3. So this 1/2 squared, this will just become 4 on top. This will become 4. Then we'll have cosecant squared theta d theta. So this is an integral, right? This is an elementary integral which we should know. And this is actually going to be cotangent of theta, and of course there's a negative outside, so we don't need to add a negative here. So we'll have 4 cotangent of theta from pi over 2 to arc cosine 1 over 3. This is equal to 4 times cotangent of arc cosine of 1 over 3 minus cotangent pi over 2. So cotangent of pi over 2, well, if you don't know that in terms of cotangent, you can think of it in terms of cosine. So cosine of pi over 2 is 0 over sine of pi over 2. Sine of pi over 2 is 1, so this is just 0. So this is 0. So our final answer is actually going to be this. But we can do better than this, okay? This does have a simple answer, so we're going to find that. So, let's arc cosine of 1/3, and you have cotangent of this, okay? Let's rewrite cotangent as cosine. So cosine arc cosine of 1 over 3, all of this over sine over arc cosine 1 over 3. Okay, so this is now 4 over 3 is 1 over sine of arc cosine 1 over 3. Okay, so now let's see how we can figure this out. Let's draw a triangle here. Let's let this angle be theta. So we know that the angle opposite of this, right, is going to be 1. And the hypotenuse, sorry, not opposite, adjacent is 1. And hypotenuse is 3. Okay, so now we need to find what is this here. In week, it doesn't really matter that we're using 1 or 3. We could use 2 or 6. We could use any ratio. Just the ratios are going to stay the same. Since we're finding sine, the ratio is what matters here. So let's now look at opposite here. Sorry, let's look at opposites and over hypotenuse. So what is opposite? Well, let's figure it out. So 1 squared is b squared equals 3 squared. Right, so we have b is equal to 2 square root of 2. So we have 2 square root of 2. Okay. So now we have sine. So we had arc cosine of 1 over 3, right? Adjacent hypotenuse is theta. Then we take the sine of this, which is just take sine of theta. What is sine of theta? What is opposite over the hypotenuse? That's 2 square root of 2 over 3. Okay? So now we have 2 square root of 2 over 3. So we can put that in there. So we have 4 over 3 times 3 over 2 square root of 2. So 3 cancel out. We have 2 and 2 comes 2 there. So 2 over square root of 2. This is square root of 2. So this is our answer, square root of 2. And this is approximately 1.414 something. So we have our answer.